Uh, Good evening, everybody. I welcome you all to the webinar titled on data analysis and reporting. So this workshop is a fourth session under the Research Guidance webinar series. It is conducted by Research and Innovation Cell, Faculty of Management and Commerce, Southeastern University of Sri Lanka. Today's resource person is Professor Dr. A. Hali. So it is my pleasure to introduce our resource person. So Professor Khalid is the head of the Department of Accountancy and Finance, Faculty of Management and Commerce. He has obtained PhD in Computer Accounting System in Management and Science University from Malaysia, and he has obtained his master degree from University of California, and he has obtained first degree in BCom and at Southeastern University of Sri Lanka. He has published many researches, especially in index journals, Scopus Index Journal, Q1 journals, and Web of Science journals. And he has presented his research in international platforms, and also he has presented his studies in United Kingdom, India, and in many other countries. He is a well-resourced person. He has delivered his keynote and other sessions in around the world. Today, he will explain a sort of idea about data analysis and reporting using SPSS. So now I invite our resource person, Professor Dr. Halim. Sir, now it's over to you, sir.
Thank you, Dr. Riyad. Good evening, everyone. Can you please make me host? I would be able to share all my slides and presentation. All right. Okay. Thank you. Thank you all participants. This is the good time to you have sessions today, and we are all meet together. And the first part is the data analysis, very important for researchers, those who are reading undergraduate and the postgraduate. No issue at all. But the thing is, everyone or the students usually think the statistics is a very hard journey. It's a tough. Everyone notices like that. But of course, so when you learn this statistics thoroughly, right, it will direct you in a good direction. So you will be able to make your journey in a good direction. That means academically, you will be able to be master, right? When you have a sound of knowledge, that's all. So actually, the figure is given by this data analysis. So what it is, why these values are comes, right? So from that point onwards, we must understand, because of that value, what are the decisions we can take, right? Today, the world is to talk about artificial intelligence, big data, and business analytics. A lot of things are talkable point right now, because based on that, the world is moving on the data, right? The huge, the millions of data they collect every day, and they wanted to get good results in order to take a decision. For that, the data analysis is very important. That is what for special degree, the university curriculum consists of for data research methodology and the data analysis as a main subject. If undergraduate or the postgraduate students get a good understanding of the good knowledge in the specific area, okay, they will win the game. Okay, I will start firstly. Mr. Dr. Riyad instructed me. This is mostly the undergraduate students and other students also participating to this program. So wanted to start with the beginning, right? How to enter the data into statistics software, as well as we have to cover this correlation and the regressions analysis. And in addition to that, the time permit me, I will be able to get to do factor analysis and all, right? EFA, exploratory factor analysis and all. Dr. Riyad, this is what is the time limit for these sessions?
So it's maximum 2 hours, sir.
All right. Okay. I'll make some arrangements for within that time. Okay. All right. Okay, give me 1 minute. I wanted to share the document right now. Give me 1 minute. Right. Firstly, we will take a look at the introductions of the statistics. Statistics is a powerful tool for decision making. Right. I'm going to start very quickly this part as a theoretical part, and no need to explain more. But of course, what the statistics give us, the knowledge the finalists give the decisions for the decision for taking a decision making. This is where all the organization, even the university or the private and the public organizations depend on that the decision making. The top level people must have a good decisions or right decisions.
Professor,
For that, what they want, the knowledge. The knowledge must be improved. For especially where it comes.
Professor, excuse me, sir.
Yes.
So the students unable to see your slides, so we
All
can
right.
go with the Explorer.
Yeah. Wait a minute. Unable to see, right? All right.
No, sir, not yet.
Okay, give me 1 minute. Right now it's okay.
Yes, sir. Yeah,
All
fine.
right. Okay. Okay, so this is the diagrams explaining what the level of statistical method and the level of improvement in decision making. Firstly, we have to start from the data. That is what many students are fail, how to analyze the data, how to collect the data, how to input the data into the SPSS and other statistical tools. Right, from the data onwards, the students may get the information, and the information transformed to the fact, and finally the students gain knowledge. Once you get knowledge, good knowledge, or the full knowledge on this particular subject, so that the knowledge can be used for decision making. This is what the basic idea why we should do data analysis, right? Okay, with that point, I'm just going to start some more things, right? And the population sampling, these things you might have learned in your research methodology area. So the entire numbers covers under the populations, and but the sample is the subset of the population, right? Okay, so the variables that you have already got knowledge on the quantitative variable and the qualitative variable. So the quantitative variables specifically focused on these quantifiable numbers, so numeric values, or non-numeric values always talk about the qualitative variables, right? So the measurement types, right? For example, I'll take to you, right? The nominal, this is what I wanted to take you first, because why? The nominal data and ordinal data. The nominal data usually called or remarked with a name only. For example, name. For example, we can call it a gender. The male and female become name, right? The blood group A, B, O, A, AB, ABO. These are the categories are called name, right? But when you look at any variables is defined by this ordinal data, the ordinal data must be, right, must be remarked with the name and rank. For example, the social economic status, we can put the top class people, middle class, or low level, like that. So there is a name one and the rank also. For example, A, B, C, D, E. A, B, C, D is called, it's put under the name as well as the rank. A is the top, B is second, and C is third, like that. So not this point, what is the data type is the nominal data and the ordinal data. This is important. That is what I just make a point on this here. And the next one, this is the SPSS data editor, because in the beginning stage, I will be like fast, because I wanted to cover more area in the rest of the area. That is what this is all, well, right? And the SPSS editors, this is the title and the tools are there. I will explain one by one how to enter the data, how to edit the data, how to modify, how to remove, how to insert everything, right? Okay. And then after, I'll back to you, right? Okay. And again, I'm going to share the second slide. So give me 1 minute. I'm going to share again. Right. So before moving SPSS software, we have to understand the statistical tools or statistical measures. Basically, the statistics start the mean value, right? The mean is, we have to focus average, 2 plus 2 plus 3 plus 4. So divided by the total value divided by the number of cases. So that is the mean. And the median, usually we talk about the middle number, right? We have learned in the mathematics, and the mod is the mostly frequently occurring values. So these are the three important values are important, because why? For descriptive analysis, we have to use this mean value and the median mod, right? So this will explain more in the qualitative directions to the reader. And when you take the measure of dispersion, the dispersions, when you look at the maximum, so in any case, any arguments or any values listed, the largest value we call maximum value, the minimum value is the lowest. And when you look at the range, so maximum minus minimum, we call this a range. And the next point is the variation. The variations cover the sum of squared deviation. So this might have covered in the mathematics subject, right? And also the statistics subjects. So the variation and the standard deviation also. The standard deviations is very important in the descriptive statistics. For example, is this the square root of the variance? The variance we should calculate variations divided by. Already we have calculated the variation. The variations come up with this sum squared deviation from the mean. Then variance comes, the variation divided by 1 less than the number of cases. That means degree of freedom, right? For example, degree of freedom. So the variations comes, right? Okay. After that, what we have to do it. This is the next point we have to note at the skewness distribution. Under the distribution, so we have to look at the two important area. One is skewness, and the second one is the curtain size. For a descriptive statistics, we have to look here the skewness. When the normal curve, when we, for example, any data we throw, right, the data must be placed in the normal distribution curve, or it must be shown with the normal distribution. So there is a skew, no skew in the first diagram, but in the second diagram, I will explain practically all these two. That means the positive skewed and the negative skewed. For example, when you look at the second diagram, it shows that positive skewed. A long tail data to the right, long tail data. For example, look at here. This is the tail data. this tail data is toward the right side, this is called positive skewed. This is what the second one, the long tail is skewed to this left, is called negative skewed or skewed to the left. Basically, when you look at your data, if the data is normally distributed, there's no problem at all at your data, on your data. But if there is any skewed value, for example, whether it's the data is a positively skewed or negatively skewed, so it will bring some problem to the data when you analyze your data. Because why? When you issue the questionnaire to the respondent may concern to answer the questions smartly, then of course you will get a real values from your issued questionnaire. If the respondents are ignorant, they don't care about the questionnaire issued, they are not looking at the question without looking the question and understand, they justly blindly tick all 4, 5, 2, like that sometime. So that will definitely bring the normal distribution problem. The problem comes firstly the skewed. Second one, I'll let you know, curtain size. The curtain size is, so for example, the curve. For example, the curve, this is the normal distribution. For example, if the data is normally distributed, there will be the less number this left side and the less number in the right side. But in the middle, there will be the most of the participants will focus on that. All right. The skewed value, I'll give you. For example, any your normal tickers like this, for example, this is called curtain size. This area is called curtain size. For example, the less number here in this area, less number in this area. Most of the numbers fall into this area, right? So this is what is called a curtain size, right? And okay, give me 1 minute. Right. So the next one, we have to talk about the data, how to enter the data. I will open the SPSS software right now, and you can see. Right. Okay. I'm going to start with the SPSS. Right. All right. Okay, good. Can you see my SPSS window?
Yes, sir.
Right. Okay. Thank you. Right. Right. This is the data sheet. I'm going to start with a new sheet. For example, if you want to start the new worksheet or data sheet, go to File and click New and click Data. Right. Okay. Right. You will get this blank sheet right now, and there will be the two options. Can you see this data sheet with the blank data?
No, sir.
With blank data? Hello? Can you see?
No, sir.
Data sheet and nothing, right? There is a two tab. It's called data view and the variable view.
Professor, we have to share the screen, otherwise people.
All right, right now. Okay.
Now okay.
Okay. So you can see there's a two tabs available. One is a data view and the variable view. Here, when you click this tab, the variable view, this tab will assist you how to form a variable. The variable can be vary, right? For example, gender. Gender is a one variable, right? Salary is another variable, right? And the question 1, for example, question 2, question 3, you see, these are the variable. How we can enter the variable here? We have to click the variable view first and click here under the name. For example, I'm going to put the gender, right here, the gender. Gender is numeric or any value. So for example, if it is data, that means the text value, we have to focus the string. This is the variable types focus. What type of data that we are going to feed into the system, feed into the worksheet? First, the numeric value or date value or dollar, customs currency or string. If it is a gender is a string, we have to click the string value, right? Okay, click OK. Look at here, it's there. And the width, how many width that we are going to put here, the decimal and the label, right? For example, if any value is going to be the numerical value, so we can change. For example, here I'm going to change the values here, numeric. Here, look at here, the label is there, and the value we can give here 1 for male, right? We can click add button. If we click add button, look at here, the male is added, and I'm going to put the 2. This is for female, right? Okay, so it's added, right? Click OK. So the values added for a gender type, male and the female. And then you have to come to this column and the alignment, no problem. And whether it is a nominal or ordinal, right? I have already focused whether what is the value for ordinal, what is the value for nominal, how to state that the nominal and ordinal. Nominal always focus on what? Nominal focus for what? Yeah, tell me. Name. Ordinal?
Name.
All right, okay. So if you are going to put the nominal, so we can click the nominal, and I'm going to put the salary, for example, salary, and this is the numeric value, this is the string. All right, okay. Right, this is the numeric values, right? Okay, and we have to we don't want to, if you are going to categorize this salary, that mean about 100,000, 80,000 to 100,000, or 50,000 to 70,000, like that. Even we can give the value here. For example, value, I will come back to this, right? So this is the way that we can enter the data, right? After entering the data, you have to click this data view. Your defined variables are here: gender, salary, the variable 1, variable, there are VAR here. A lot of things are here. Under this, so you can define many variables, right? Okay. So gender, for example, if you are going to put 1, right, it is defined what? 1 is defined what? I'm going to put here 1, okay, 1 and 2. You can put 2 very simply, entering the data, right? When you look at this mark, look at here, my value label, right? When you click this, automatically it is giving this a character, that the string values and the numeric values. Once again, if you click here, for example, male values are here, right? This is called string, right? And when you click this, once again, if you click this, automatically it comes for numeric value. So this is the way that you can enter. For example, if you wanted to insert a row, right, or you can easily select this line, right, insert a case, for example. If you click, right, okay, this case is here. Okay, I have typed here 1. And if you want to delete this one data, what you can do, you have to take your mouse pointer on this bar, right, the headings bar, row headings, and clear. The button is called this, the letter is called the clear. If you put clear, so the data is clear. Right. This is the basic. This basic is enough how to enter the data. Right. How you can enter the data into the data sheet. Right. I am directly going to come to the going to put you descriptive analysis first, because I have to cover many area. That is what I'm just taking speed on these sessions, right? Okay, how we can enter the data. First we have covered, and I'm going to take the descriptive analysis, right? For example, you may be a student. A teacher is conducting exam, the statistics subject, where there are 40 students or 50 students, and this teachers collecting the marks after the corrections, the question after the correction the paper. So he or she collect the record their marks. She wanted to analyze the data, how these marks are plotted in the class, right? How many students got the highest marks? How many students got the lower marks? What is the maximum marks? What is the minimum marks? What is the average marks? What is the median marks? So she wanted to get that marks, right? Okay, give me time. Give me for 1 minute. I'm just sharing data to you right now again. Right. All right. Okay. Can you see my slides right now? Hello?
Yes, sir.
Yes, this is the worksheet. I already entered the marks, and this is the working time. No problem. You don't look at that as the second one. Now we have entered the marks first. Up to look at here, there are 60 data is are available. Look at how to enter the variable here. We have to click on the variable view. So this is the marks, numeric. Width is 8. Width mean you can even put a 10 or whatever you want, right? No problem at all, right? If the any values comes for example, decimal values, if you want, even you can put 2 decimal or whatever, or 3 or 4, whatever, right? Or else you can make 0, right? The label, even you can define the label marks. What, for example, statistics marks, right? Okay, statistics, I'll put marks. Okay, you can put the label here. So for the marks, there is no values, and the missing value nothing. Columns, alignment, you can put to the right alignment, left alignment, or center for the data, right? And after that, you have to put here whether the scale, ordinal, or nominal. These are the 3 measures are available, right? You can put a scale, right? After that, this is the first defining the variable, right? So we have here only 2 variables we have defined, right? For example, marks, and the second one is a W time, for example, waiting time, right? So once you define the variable, then you have to take a move to entering data. The entering data, you can simply enter the data here, right? So after entering, what we have to do it, we have to firstly look at the first section, the descriptive analysis. So how we can do this descriptive analysis, right? We have to go to, there is this, the title bar is there. One is a file, edit, view, data, ransom, and analyze. So we have to click this analysis button. This is the button is available. Once you click, right? So the lot of techniques are available under the analysis. Look at here, the descriptive statistics, custom table, compare mean, general linear, mixed method, correlation, regressions, a lot of things are there. But we have to focus on the descriptive statistics here. The firstly one, frequencies, descriptive, and explore, right? What we are going to cover today, explore, how we are going to explore the data, exploring the data. For example, we have collected 60 marks after conducting the examination, statistics examination. So we must know how this data is recorded, how the data is going to give the information for decision making, right? So based on that concept, we have to click on this explore. Right. When you click this explore, we can look at this the big tables here. All these variables are placed here, and in your right side, the dependent list there, factor list there, label keys by. These are the three blank boxes are there. If we wanted to move here, we have to select this one and click this arrow button. You can have a move to this marks. Look at here, statistics marks. Already, this is the variable that label I have given. Right. Okay. Under the statistics, what we have to then what we have to take a next steps. Click the statistics. Okay. This is where you can put the descriptive and the outlier, for example. Right. You can give this outlier. And after that, you have to click continue. Right. Okay. Next button is the float button. Right. You have to click this float. And when you click this float, right, by default, box plot is the factor level together. And here, the descriptive also is there, stem and leaf. Right. So then what we have to do here, we have to click histogram. I'll explain to you how this will be interpreted. And the next one is the normality plot with test. Normality plot with test. Okay, so this is enough, right? Once you click this normality plot with the test, click continue button, and you don't want to do anything for the options. For example, here no need to do it, and the bootstrap also no need here. But under the display, we have to look at the both, all right? Both, not the statistic and plot. If you click the statistics, only the numerical reports will be there, that is statistical report. But if you click this both, plots and the statistics will be available. Plots mean all diagrams will be available, right? Okay, click OK. So can you see my output? Can you see my output? All right. All right. Okay, got it?
Sir.
Hello, can you see?
Yes, sir.
Right, okay, good. The first output, once you click OK, of course you will get the second window. The window is called output window. Look at here, the heading is there, output window. Even you can save this output window in your directory or any folder, wherever you want. All right. So you can save it. The first output table says the case processing summary. How many numbers that, for example, how many marks we have entered? 60 numbers. So the percentage 100%. Is there any value missing? So all 60 marks we have. So that is what, there's no missing number from the data. All right. For example, without entering any numbers, we have just moved to the next one. So that will be blank. If it is a blank, that is called the missing value. So there's no missing value. So the total 60. From this second table is called descriptive table. So what you can do, what you can see from the descriptive, a lot of things we can understand. Firstly, the mean. Mean value is mainly important for the descriptive, statistics, not only this descriptive, for the statistics. Here we can understand there are 60 marks available from the student side, right? The average, mean is the average, right? For example, 2 plus 3, it should become 2.5 is the average. Because why? The two numbers are available, 2 and the 3. So the total case is here 2. So 2 plus 3, 5. 5 divided by cases. So it's mean average. So the mean value gives the average value. Average marks is a 64.75. So what we can understand from the exam conducted in a statistics subjects. So in the particular class, the average marks gained by student is 64.75. So the exam is quite okay. There's no more. If it comes below 50, like let's say average is 35, so the students say this exam is so tough, it's so hard, I couldn't sit the exam. Sometimes the average marks may be like a 80 or 85. That means all the students happy. They are so satisfied. You know, they are all the average marks is the 80 marks. So they will say like that it's very easy like that, right? But the next one, we will look at the median. The median is the middle number, right? For example, we have a 60 numbers. We have to arrange the number into ascending order or descending order. When you arrange the number in ascending order, descending order, we have to point the middle number, right? So we can get the 65 is the median values. For example, if we arrange the number 1, 3, 4, 5, 7. So these are the 5 numbers, right? So the third number is called the median number. So what is the value for the median number? So it's called the 65. When you look at these two numbers, mean and the median, so the mean and the medians are very closer values, very closer. So then there is no issue in this mean and the median. Because why? The mean value is a 64.75. The median also it's a 75. So the median value means the 50%. 50% of the students, right, in the left side there's another 50%, in the right side another 50%. So in the middle, 65 marks is there. So look at the marks trend. From the 65 onwards up to 100, another 50% of the marks is fallen. And when you look at the left side, another 50% marks are fallen. For example, there are 60 students. So 60 students in the 30, the right side is 30, above 65. Left side 30 numbers, 30 students marks are there below 65. All right. So this is called the median. And the next one, standard deviations. When you look at the standard deviation, we have to compare the mean and the standard deviations. Standard deviations, the variations of the number is calculated based on the standard deviation. This is the 64.75 plus and minus 9.278. When you add with the 64.75 with this 9.278, so this is the positive values, right, to the right side. When you put the minus 64.75 minus 9.278, so the range start from this 64.75 minus 9.278 to 64.75 plus 9.278. Okay. So the next one is range, maximum and the minimum. So from the 60 marks, minimum marks, students got 45 marks. So from this subject, the minimum marks, so it means there's no fail. Above 40, no? Above 40, there's no fail. So the minimum marks students got is 45 and the maximum marks 87. So this explain the minimum and the maximum. And the range is there, 87 minus 45, 42 marks, 42. So all the marks, all 60 marks are fallen, going to fallen within 45 to 87, between 45 to 87. So this is a good information, right? And the next one you have to look at here, skewness and curticized. That is what I have mentioned in the second handout. That means in the PDF file. So according to the skewness, this is a 0.148. So what do you understand? The normality curve. For example, when you draw the normality curve, this is the normal diagram, right? This is the plus, right? 0.148. So this is the positive skew, the positive skew. Long tail of this diagrams says that 0.148. Statistically, for example, for social science research, right, we can accept plus or minus 2, or some researchers argue we can go for 5 also. But if we go the maximum value for a 2, so you can look at the data will be normally distributed, right? And when you look at here, for example, if it is like this, for example, mine plus 2.578 sometime, 2.78. So this will bring more problem sometime, right? If it is a more than 5, or if it is a 10, so I already explained, the respondents are not looking in the questionnaire, right? So these kind of the issues will come, the multi-collinearity problem also, right? Okay, I will let you know little later. Right, okay. So then the criticized values also, this is minus 0.042. This also must be fallen between 2, plus or minus 2. If it is so, the data is good. We can have an assumption the data is good, right? Okay, so the next we have to come to here, the extreme values. What are the extreme values we have found from this data? For example, marks, first to 5. So the 5 marks are taken here, right? This is the case number. For example, the student's registration number. So we have 50th student's marks, or 42nd student's marks. This is the 24th student's marks. This is the 10th student's marks. Okay, the 50th students got 87, and for example, 50 students, he got 79. So all these are top values are listed here. That means all 5 top marks, 87, 85, 83, 81, 79. When you come to this lowest values, there are 5 marks we can take. For example, 45, 48, 48, 50, 50. You know what is the maximum marks and what is the minimum mark. Already in the descriptive table, it shows that the maximum marks is 87 and the minimum marks is 45. And the next one, this is the very important point, test of normality. Right? Okay, I'm going to draw the diagram, normality curve, the normal distribution curve, right? This is the normal distribution curve. This is the 50%, right? Okay, if the curve is fallen like this, the data is normally distributed. For example, in the class, we cannot say all the students are getting more than 80 marks. So if it is so, in the class, those students are the extraordinary students, powerful, talented students. Sometimes there may be poor students, they will get less marks, right? So the most of the students will, students may get a marks from 40 or 40 to 70. But the small number of students may get more than 80 and less than 40. So this is the normally happen everything for everywhere, right? Okay. So the normal test of normality is there. 2 tests available. One is Shapiro-Wilkie test and Kolmogorov-Smirnov test. So if your sample size is less than 50, for example, if your sample size is less than 50, you have to use the technique Shapiro-Wilkie test, right? If your sample size is S is greater than 50 numbers. So what is the sample size of from our data? It is a 60 numbers. It is a 60 sample. So we have entered the data for a 60 marks. So that is what our sample size is, 60. Right. When you look at this 60 sample, right? So what we can do, we have to use this area for reporting, not this area. All right, we have to close this Saprivilki test, but we have to use this Kolmogorov Smirnov test. Look at here, right? The significant values, right? So this is the statistic significance value, see the normality test, or according to the Kolmogorov Smirnov test. If it is a p value, this is the significant p value is greater than 0.05. All right, if it is greater than 0.05, it says that the data is normally distributed. Data is normally distributed. How we can prove the data is normally distributed? Okay, I'm going to come to this second argument, how it says that the data is normally distributed. Okay, look at here the histograms. When you draw a line in the middle, connecting the middle values, for example, right? Okay, sorry, okay, this way, this line shows the data is normally distributed. So this is the normal distribution curve, right? Okay, so this histograms also shows that the data is normally distributed. Okay, once again, I'm going to show you the argument how this data is normally distributed from this stem and leaf plot. This is the stem and leaf plots usually will tell what, how many stem, how many leaf, for example, leaf. For example, the stem, there are 3 numbers, 3 marks available in the data, data set. For example, 45, second marks are 48, third marks also 48. So this is what, this the first, the second digits, right? 4. So there are 3 marks is there, 4 and 5 decimal, right? The 4, 45, and second 48, third 48. When you look at here in the next level 5, there are another 5 marks is available. 1 marks is a 50, second marks also 50, third marks 51, and the fourth marks is a 53, and fifth marks is a 54. When you come to this area, 8th level, there's a 2 marks is available. One is 85, and second marks is 87. Again, this level, look at here. There are 2 marks is available, 81 and 83. You understand? It's clear to you? Right. Again, based on this plot, you can look at the data. I'm just drawing a line here. Look at here. So this line also, so the data is normally distributed. Okay, look at here. The most of the numbers, most of the marks are fallen this area. Look at here. Most of the students got this 65, 65, 65, 65, 66, 67, 7, 7, 7, 7, 8, 8, 8, 9. And also look at here. The most of the students got 60, 62, 63, 64. And again, 70. So this is the major marks, right? But the less marks are fallen in this area, these 2 areas. Right, I'll just draw this again. These 2 areas are less numbers, right? So we can have a proof one way how this data is distributed. First things, we can find the table here, the test of normality. The test of normality will explain how the data is normally, whether the data is normally distributed or not. According to the test of normality, right, a Kolmogorov-Smirnov test, if the p-value is greater than 0.05, the data can be assumed it is normally distributed. Second, we have to come to here histogram. Histogram also say another valuable argument. The data is normally distributed. Third, stem and leaf plot also explain the data is normally distributed. And the next one is normal QQ plot. That is what we have selected, both statistics and plot. So the statistical part is explained by this descriptive table, and these diagrams and the plots explained by these histograms, and stem and leaf explain all the plots. That is what we have selected both. Okay, now we have to come to here the normal QQ plot statistics mark. Look at this diagonal line. Look at this diagonal line. This is the diagonal line, right? From on this line, the data are very close to the line. Only few area. Look at here, this area just away from the line, just away. If any values here, for example, if any values are here, right? This will make outlier from the line. They are far away from this line. The numbers may be far away, right? For example, in your class, from your class, you are going to make a trip to somewhere else, historical place or entertainment place, right? You are just organizing a trip, right? What will you do? A person is very naughty, right? Always just making disturbance to everyone. He is always talking about the negative aspect. He is not always cooperating with the team members. What will you do when you arrange a trip? Whether will you take him to the trip or whether you drop and go? Very simply, the most of the people will try to ignore the persons, because we are going for a trip for enjoying the day, enjoying the climate, enjoying the natures, right? So because of that, if any person comes with you disturbance, making disturbance by the one or two guys, always making in such a naughty works and all, so will you be able will you be able to enjoy the trip successfully? No, it's making problem to you. So that is what in statistics, if there is any outliers happen in your data, we have to remove these. We have to remove. If you remove only, you will be able to get a good data. That is what it's called. It is defined under the data screening. Data screening, or another word we can call data cleaning also. After collecting the data, right, from the questionnaire, what we have to do, it is the first steps that we have to do data screening part. Under the data screening, we have to look at, is there any outlier in the data set? That means the abnormal data. If there is any abnormal data, what we have to do according to this rule of thumbs, that means the criteria, we have to remove the data and straight away you take for your analysis. That is what you prepare the trip and go dropping that the guy who make trouble to the all people. So this is the decisions, right? Okay. So I'll remove these all drawings, right? Then the next, right? So look at here. This also will show you the outlier, but there is no outlier. I will show you how this data set will bring outlier to you, right? If the data is available here, this is the line called the median line, right? and this tail is upper tail and this lower part. So this is the line is called the mean and the median, right? This is two, right? Two area. If the line is fallen within in the middle, the halfway on this box here, here, and here, halfway, so the data is good. We can have assumptions the data is good, right? Okay, I'm going to run this data again. Give me 1 minute. I'm going to share the previous data. Okay, so look at this data. This is the data that the data that we run usually. In the last point, look at here the last marks. What is the last marks? What are the last marks here? 64. Am I right? I'm going to change this marks to 20. All right. You understand? I have changed this value 20. Okay, I'm going to run this. I'm going to run this again. Descriptive, explore. So already is there, setting is already there. If you are going to set it newly, we have to put the reset. The reset automatically remove all the settings because we have set something in this explore area in the statistics, descriptive, outlier, and all. And the plot also we have set something histograms and normality plot with a test and all. So if you are going to reset, all the settings will be clear without any additional settings. Okay, if it is so, then we are going to run this clear. Okay, right. So this is the new output. What we can see here, mean value is 64. Look at the earlier it was here. I wanted to share to you, right? Okay, so please remind if I make any mistakes, right? Okay, can you see my output? Okay, this is the 64.75 earlier. Now look at the new output is called 64.02. And skewness also, it was earlier. Look at here, the skewness value is a 0.148, but here the skewness value is here minus 0.904, and curtain size values also increased, right? Okay, that because of that there will be the problem. Okay, I'll see here, right? Once I have changed the value for the last student's marks, it was 64 lately. I have changed it to 24, 25, 20. Okay, all right. So look at here. There's a gap between the 20 and the 40, 45 here. I think so. There may be 45. So there's a big gap, right? And I'll bring to here this diagram, normal QQ plot statistics. When I change this number, look at here. When I change the values in this earlier normal QQ plot statistical diagram, all these values have fallen on the line, on the diagonal line. But once I change this value, only it's deviate from this line, away from the line, away from this diagonal line. So look at here. So because of this, there will be the problem, right? I'll bring this problem to you. I'll show you this problem. Okay. Look at here. Look at here. This is what is called outlier. Look at, you can understand. This is the case number, 60th student's number. So one value is away from this outlier box. So this is what, this is a making problem to the normality distributions curve. So that is what you can look at here, the normal distribution problem. Right. Okay, look at here. There's a problem in this line. And look at here. It doesn't show any normality. This is the statistically says that there's no problem because the most of the 59 students' marks are in a linear marks, right? But except one student who got only 20 marks. Because of that, the problem is there, right? Okay, look at here. This marks is here, and Because of this, we can see there is outlier. Okay, how we can draw the outlier separately? For example, if you are going to draw this outlier, wanted to find the outlier separately, you can look at this graph is there. Look at the graph, right? Legacy dialog. Click on this legacy dialog and click this box plot. Okay, make this a symbol. Under the box plot, click on symbol. The next one, the data in chart are summarize of a separate variable. Click on this summaries of separate variables. Click define. Once you click, you have to take a move this statistical mass to this box represent area. No need other area, and click OK. Look at the same box is placed. This is the way you can see all variables into this diagram. Once you look at here, you can understand what are the values are covered by this outlier. What are the values are covered under the normal distribution. Okay, so this is the first section. It's over right now. Once you understand the descriptive area, easily you will be able to describe the data very simply, very easily. All right. Okay. Now I'm going to have a move to the next area is categorical data. How we can describe, how we can analyze the categorical data, and how we can able to interpret the data. Okay, give me 1 minute. I'll open the file and open and file first. Okay. Okay, can you see my grade? There's a two areas available here. One is the grade, and second, this is the BMI, body mass index, right? For example, grade, the students got the grade point. For example, A marks, B marks, C marks. A lot of marks are available up to 60 marks, right? We have placed 60 marks. So this is the grade. Look at here. This is the grade string. That is what I put to the grade. We can term is a string, right? And other things are no issue at all. And click the data view. And how we can have analysis on this, descriptive statistics. Go to here, analysis. Click on descriptive, and click this frequencies. Click on that. Okay. Once you click the frequencies, you have to have a move on this grade to this right side to the variable. Okay, the variable is available. Click this chart. Click this chart. What type of chart that you want? What type of chart? For example, bar chart, pie chart, histograms, whatever. If you want, you can click on. For example, I'm just click on this histograms, and click continue. And the next one, the statistics. So if you want the mean, for example, grade, we cannot find the mean value, median value, mod, and summations we don't have, and standard deviation we cannot find, minimum, maximum we cannot, skewness and cutter size. Okay, click continue and click OK. So you will get the descriptions. For example, I'm going to share this to you. Okay, now you understand. There will be the grade 2 points there, 2 tables there. One is a grade table and the next one. So its frequencies is here, A, B, C, D, E. All five grades are here. And how many numbers, frequencies? For example, A got by 4 students, B got by 12 students, C got by 28 students, D got by 13 students, E got by 3. So the percentage also it's there, 6.7%, 12 for a B grade, 20%, for a C grade, 46.7%, D grade to 21.7%, and the E grade for 5%. Okay, so these are the categorical data. Even you can very simply analyze this data. Okay, now I'm going to have a move to the bigger area, correlation and regressions analysis. For example, undergraduate students, so most of the undergraduate students, they focus on usually they focus on the correlation and the regressions based on the problem statement and the objective, right? So for example, they wanted to have objective to examine, to understand, to study, for example, to measure the association of the independent variable and the dependent variable. Second one, they wanted to measure the impact of independent variable and dependent variable, right? I don't want to take the time to lessons on this methodology area, right? So the variable independent and the dependent variable, right? Briefly, I'm telling. So this is what usually the object is defined. So based on the research question, and the previously we have to focus on this research problem, right? So from the problem we have to form the research question, and then we have to form this objective, right? After that, for meet the objective, we should have the proper tools. What is the tools that we are going to use for justifying our objective? So that we are most of the students, most of the research use correlations analysis and regressions. The correlation is explain the associations between independent variable and the dependent variable, right? Okay, now you are ready. You have developed your methodology. That means the conceptual framework. For example, conceptual framework, it means shall I draw a diagram, some model to you? This is the variable IV, independent variable, and the second variable is called this is IV1, independent variable 1. This is independent variable 2, and this is the independent variable 3, for example, right? So these are the three variables are there. You are going to form a model is called, this is the very simple model. That is what I'm drawing here, dependent variable. Okay, that's called the DV, right? Okay, you have to prove your hypothesis will be accepted or rejected. So you have already formed a hypothesis 1, H1, H2, and H3, right? Okay, so for this is the main area of your conceptual model, from which what you have developed a questionnaire, right? Under the operationalization and all, you have developed a questionnaire. For example, for IV1, IV variable 1, right? That's a variable 1. You have developed a question 1, question 2, question 3. This is question 4, right? You have formed 4 questions. So basically, you have taken this under the operationalization and the measure of the variable, right? From the literature, you might have collected these all, and after that, you develop the questionnaire. For independent variable 1, you have developed 4 questions in order to measure those independent variable, right? Okay. Likewise, for the second variable also, right? Variable 2, and for a variable 3 also, right? For an independent variable, right? Okay. Again, for a dependent variable also, you have developed another 4 questions. For example, right? For a 4 questions, DV question 1, right? Here, DV1, for example, DVQ1. I'm just putting code, right? Okay. This is a DVQ2, right? And this is the DVQ3. All right. Here, dependent variable Q4, right? Up to this, you have developed a questionnaire, and finally, you have validated everything that you have done. And now you are going to issue the questionnaire to the particular respondents, right? According to the study, you are going to issue, for example, it may be the customer, it may be employees, or some other people, right? Okay, no problem, right? You have issued, and you have collected, let's say you have issued a 450 questionnaire as a respondent, and finally you have collected 310 question. Only you are going to feed the question into this SPSS 310. After feeding all this 310, what you have to do it, you have to run the data screening and all, and finally under the data screening you have to test whether the data is normally distributed, and is there any outlier in the data. And after checking and all, you are now just now ready to analyze the main area of the correlation and the regressions based on your objective. Okay, I'll again I'm going to some share a document to you. Okay, give me 1 minute. All right. Okay. All right. Okay. So this is what, for example, you have recorded your data. For example, I have an example here, str1. This is the coding, right? The variable we have defined, we can define the variable, right? str1 is a one variable, right? str is a one variable for a question, str1, question 2 str2, and question 3 str3, question 4 str4. So this is what this is your questions, right? So like that, there are a lot of variables are available. str is a one variable, tec is second variable, com is the third variable, inv is the fourth variable, bme is the fifth variable, and map is the independent variable. For example, how many variables here? str1, t2, 3, 4, 5, and 6. So according to this, the model is like this. So for example, the simple model, I'm just drawing the simple model. All right, there are right. Okay, this is the model, right? I'm just drawing this simple model. Right. For example, we have to draw here. This is the str. For example, str, and this is the tec variable, and this is the com variable, and this is inv one more, right? Okay, yeah, right. Okay, I'll show that. I'll draw this. All right. Okay, and this is the bme, for example, bme, right? Okay, so the dependent variable, okay, map. All right, map. So here, okay, from this model, right? Okay, you have to put a arrow mark like this to all your independent variable, because this is going to influence on this map. That is what you put h1, h2, h3, h4, h5, like that you have developed. Okay, so from this conceptual model, what you have developed a questionnaire, right? Shall I remove this and all? Right, you have developed and defined the variable, all numeric variable, right? And after that, how you define here, right? I'm just going to take the first one, string. This is the Likert scale. 5 Likert scale data that you have put. That means 5 mean 1. For a 1, number 1, you have put the mention very strongly disagree. For a 2 that you have mentioned, strongly agree. So, right, that means strongly disagree. 1 is strongly disagree. Second one, disagree. And the third is neutral. Fourth is agree. And fifth one is strongly agree. So by focusing this 5 Likert, you have developed a question and issued it, right? Okay, so that is what we have put the values here. And after developing this, what we have to do it, this is the demographic data. For example, age, gender, and salary status, number of members, occupation. There are a lot of things are there, right? And you have to click on this data view. From the data view, you have entered all the data. Look at here. There are first respondents data. First respondents. right? So here from the collected data collected questionnaire, and these values are there available 3 4 3 3 3 3 4 4 4 like that. There are a lot of he has mentioned a lot of things, right? Okay, a lot of things, right? Look at here, right? Okay, okay, right. I'm going to remove this and I'll come back to you. It's very simple to me to explain to you. I'm just click strtc, removing this all, right? Removing this all right. Okay, right. Okay, so I have removed this all, and now you wanted to find the value for your independent variable. Value for independent variable. Let's say, so this is your model. I have already explained to you. This is the model I have explained to you. All right. This is the str, and so we have to find the value from the data, from the value. One value, we have to find one value. So how we can get the value from the data set, right? So basically, we can find the average value. Usually, the most of the students, most of the researchers takes the average. So how we can get the average value, right? Okay. So simply, if we wanted to find the value for str, what we can do, there's option is called transform. This is called transform. Click the transform button and click the compute variable. Compute variable, and we have to define the variable name here. The first variable is str, okay, and we have to numeric expressions. You have to click here and click the functions group. Click this all. Click the all button, and under there are another table is there under these functional groups. We have to click on this and we have to type the letter M, mean. I'm going to search mean value, right? The mean is here. Double click this on mean, right? Automatically this mean is available here. To find the average value, what I'm going to do, what I'm going to find here, the average from this 4 sub variable. Let's say, in other words, it's a sub variable. Okay, right? Don't take differently. It's a sub variable. I'm going to have a move to here. Double click on this first and put comma. Double click this second one str, put comma. Double click on third one, put comma, and fourth. Okay, finally you have to remove this comma and question. After that, if you click OK button, automatically the system will find the average value. Okay, I'm going to click this OK. All right, I'll show you here in the data sheet. In the last column, look at here. This is the defined term. We have defined the term str, and the system found the average value. Automatically, the average value is available. Like that, we have to do another 2 more, and we have to define here the second variable. I'm going to put the TEC. All right, and I am going to remove these values inside this double bracket, and I'm going to place the TEC1, comma, TEC2, and TEC3, and TEC4. All right, now TEC1, TEC2, TEC3, TEC4. So for this all values, we are going to find the average. Okay, now it is there, and you can look at that. Can you see? Right, so TEC also is there, right? And then again, like that, we have to have a move to this third variable. I'm going to have a move to this com. For example, I'm going to have a com, COM, right? I'm just to make into capital COM. All right, okay. I'm going to find the average for the variable com, right? We'll move this variable 1, 2, 3, 4, like that. Okay, It's happened, right? It's happened. Is there any problem? Let me know, right? Okay, all three. For example, I took here three independent variable. Example, I have selected three independent variable, and I'm going to have a move find to this next the dependent variable. Again, I'm going to click the transform compute variable, and I'm going to have a move to this dependent variable MAP. So I'm going to put here MAP and bring all these four values or sub variables to this column, MAP1, MAP2, MAP3, MAP4. All right, MAP4 I have brought down here all these values. Okay, now I'm going to click OK. Right, now you look at the variable. There are, can you all see my all four variables? Four variables here: str, tec, com, and map. So these all four variables are available. So the first one, str, is an independent variable. T is also independent variable. Com also independent variable. Map is your dependent variable. What we are going to do right now, we are going to find the correlations. Correlations. Okay. If you wanted to find the correlation, click analyze, and there is a button is called correlations button. So look at here, bivariable, right? Bivariate. So the SPSS statistical software, univariate, bivariate, or multiple variate, altogether the bivariate options are used, right? Okay, univariate is just comparing only two variable, right? Only two independent variable. But univariable is usually called for a one variable, one independent variable. Multiple variable, more than two variable, more than two independent variable, right? So we have to click this bivariable. So now we have all variables under that. We have formed this here, and select this and move to the right. Move to the right. Okay, variables are available. No need to do any options under this or style or whatever. Only the Pearson correlations. For example, there are some correlations techniques are available. One is a Pearson correlation, is PMN correlation, and this is the test is going to be used for the test of significance, two-tailed test. And after that, we have to click OK. Right. Okay. Now look at my output. All right. Can you see my output? Can you see? Right. Okay. So what we have to do it, this is the output we can get from the SPSS. We have to compare, we have to take a write-up. What is the relations? What is the association? Not the relations. What is the associations between the independent variable and the dependent variable? So we have to firstly compare the independent variable str with this MAP. And TEC and MAP, com and MAP. So only three variables that we are going to compare. The first value is the R value, correlations value. This is the correlations value. This is the correlations value. This is the correlations value. So we have a three correlations value. The correlations between str and the MAP. So it's called R equal 0. This is the value 0.256. So this is the value we get from this output. And the second one is called the P value. So look at here, significance, two-tailed significance. So P equal here, P equal 0.001. Look at here, 0.01. So this means this str and the relationship association between str and the MAP, according to the statistical output, statistically there is an association. There is an association between str and MAP. Because why? The R equal R. For example, R, small r, don't put a capital R. R equal 0.256. It states that there is a correlation between str and MAP. So according to this, P is equal 0.05. So we can have a conclusion this relationship, this association is statistically proved. That means the P equals 0.001, which is less than 0.05. So based on this criteria, for example, if the p-value is less than 0.05, it says that the relationship is statistically proof. Okay, so statistically we are going to prove it. So there is an association between STR and MAP. Second proof that we are going to bring it, TEC and MAP. So here the TEC, for example, TEC R equal 0.215. 0.215. Okay. Here the p-value is equal 0.007, which is also less than 0.05. This is the rule of thumbs. So why we are going to take this probability value, p-value, 95% confident. So there will be the association. There is an association between TEC and the MAP. And the third also, look at the third also, the COM. So the association between the COM and the MAP, the R is 0.392 and the P is 0.000. So this means it is a significant at 1%. It is a series. P is, for example, P equal 0.000 is less than 0.01, right? 0.1. So because why? This is the zero values. So when you put the fourth decimal or fifth decimal, sixth decimal, 10th decimal, there will be the value. There will be the value less than this value. So because of that, we are going to explain this. This is statistically the P is less than 0.01%. Okay, that's all for the correlations, right? The correlations is that's all, right? And the next one is the regression. The regression is going to explain us the explanatory power of the variable. Give me 1 minute. The charge is getting less. All right. Okay. So next the sections we will have a move to. We will have a move to regression analysis. Okay. Right. We'll have a move to these regressions, how we are going to move to. Even we can directly go to this analysis, click analyze. And there's option is called the regression. So the next level is we have to move to here linear regressions, all right? Linear regression. So I'm going to reset. All right. Okay. Reset. And I'm going to remove this all. Okay. All these drawings gone out. And once you click this, you will get this table. Right. Okay. You have to look at this dependent variable. Take a dependent variable. Click on this and click the arrow mark. And after that, you have to select one by one or together, no problem. Right, by pressing the shift key, you can select all these three, right? And have a move to this independent. All right. So now we have defined the dependent variable and independent variable. Right. Then we have to have a move to the statistics. Right. We have to click this R scar, right? And collinearity diagnostics, and the next one, the case-wise diagnostics. From the statistics, we have to click this descriptive and the collinearity diagnostics, case-wise diagnostic. Okay, click continue and have a move to plot. Right. Okay. Now we have to have a move SPRED. Click on that. Click to this X. Next, ZRESID. Select this one and click to Y-axis. Right. And click continue and save button. So we in this SPSS, for example, call regressions values, we have, if you wanted to find unstandardized value, we have to have a unstandardized values, right? Click unstandardized and click continue. And after that, to click options. No need to click anything. Continue. Style also no need. Okay. Then click OK. Right. So once you click this, okay, then you will have my output. Okay. Now we have to look at here the R value. R is usually the relationship, the correlations value 0.405. And R scared value, we have to mainly look at this R scared value. R scared value R into R, right? So this is the value is 0.164. 0.164 means 16.4%. So in the social science research, at least minimum we should have, should have 20 or 25%, 20 or 25%. But if it is less than 20, 25, what to do, right? This is basically based on this data only, we can get these values, right? And the second thing, so we can get it, for example, the model, ANOVA. Overall model means we have taken 3 independent variable and the 1 dependent variable. So we can conclude that this model is a fit. According to the data set, the model is a fit. That means the model we have found. For example, let's say every year, Toyota company or Benz or BMW or Honda, whatever companies, they are producing new type of model of a new car, right? And they test the car in the test trialing in the plant, and after that they put into the market, right? From the testing, they conclude that the new model of the new car is good. So like that, based on this, our research conceptual model, the model is significantly supported. Because why? How this we can conclude that the significant values here, this significant values state 0.000, right? According to this result, the p value is less than 0.05. According to that, we conclude the model is a fit, right? The next one is coefficient table. We have to look at the coefficient beta value. This is the unstandardized coefficient beta value. So usually the linear equations model is y equal a plus bx. A plus bx is called linear equation, right? So the linear equations mean this is the dependent variable that we are going to look at, and the b is the our variable and x is the values, unstandardized values that we are getting. For example, what is the dependent variables? Here we have got MAP. Look at here, the MAP, y equal MAP. Look at here, this is the dependent variable here, and a is the slope. Here the constant value we are getting equal 1.256. 1.256. Okay, b is the independent variable. For example, str, b is the str, the independent variable. We call it str. What is the value for the str? 0.163. And the next one is a TEC. TEC, right? TEC, right? This is called 0.104. And the next one, look at here, COM. I'll put under the next line, for example, as the line is a shortage, 0.347. Okay, this is our linear equations, right? Y equal a plus a bx. This is the linear equation. According to this finding, so really look at here the p-value of these three variable, except this COM. Other two is rejected, except this two, except this COM, the two is rejected. So we are going to measure the impact of this variable to this dependent variable. So this is the STR and the TEC is rejected. For example, this is rejected, TEC is also rejected. So according to our adjusted model, the final model, our final model. So what is the impact power of these two independent variable? STR is not statistically significant, and TEC is also not statistically significant. Because of that, we have to reject the alternative variable that means H1. H1 is rejected. Okay, and here the H2 also is alternative variable is 2 also rejected. So these two only accepted this one. 0.347, that means the COM. So y equal a plus bx, that means the COM 0.347. So 0.347 is the adjusted model. So from this coefficient table, we can conclude like this. And in addition to that, we have to test the VIF value, mean the multicollinearity issue. Multicollinearity mean, so look at the collinearity statistics, right? So the collinearity statistics we have to test here. According to this collinearity, this value, if it is less than 5, it is okay, good. Even for some studies, some statistics says that they can go for even 10 also, right? There is no problem, but this is according to this according to some research findings. So some researchers says that it is a substantial. If, for example, if it is a VIF value is greater than 0.5, it is a substantial. But if it is a 10, greater than 10 is it is a serious. So there will be the issues between independent variable. But when we look at here, this is all this less than 5. If it is a less than 5, means there's no serious problem between independent variable. That means I'm just going to remove this and after that I will be able to explain the multicollinearity issues, right? Okay, just to have removed, and we have a 3 variable, variable 1, variable 2, and variable 3. Okay, so this is the MAP, okay, and STR and TEC. All right, TEC and COM. Right, okay. So according to this, right, we have taken 3 different variables. 3 different. STR is the different concept, and TEC also is a different variable, and COM is also is a different. But the multicollinearity problem means if there is any similarity between these 2 variables, for example, this and this, if there is a similarity or homogeneity, for example, these 2 variables are similar cases. If that are the similar cases, there will be the problem. Here. If it is a more than 5, for example, any variable STR is more than 5, let's say. So it's mean the multicollinearity issues there between these 2 variables, STR and the TEC, for example, right? So this is, if the problems come, so we have to remove that variable. For example, STRs comes like for example 6.78. It means the multicollinearity problem is there, so we have to remove from our model. For example, we are developing a new car, we have put now new features on that car. So what we have to do, if the same features is already added as a one variable. If it is so, no need to put this similar variable in the model again. So another option is available to prove this multicollinearity. For example, we have to look at the agent value, right? Agent value. So look at here, right? Agent value. The agent value is here under the collinearity diagnostic. If the value is closer to 1, if it is closer to 1 or the less than 1, right, no issue. If it is a more than 1, if it is bring the more than 1, for example, it will bring multicollinearity problem. It will bring multicollinearity problem, right? So that is the way that we have to look at here. And so this is what we have to look at. Okay. The next one, the residual, right? Residual. I'll show you these residuals values created in this data, right? So look at here. I'll share this data sheet. Okay. Look at here. The last corner, last values. This is the residuals values are created here. So because from this residual values, what we have to do it, we have to find the normality test, right? A normality test. We have to test the normality, right? Right? How we can test it under the descriptive. We have to click this descriptive and click on this explore, and have a move to this unstandardized residuals value here, right? Statistics. Right, no need to put anything, right? Outlier, okay. And the plot, right? Okay, this is the normality plots with this test, okay. And options, okay, and click OK, right? Okay, so again I'm sharing this report. We have to look at this test of normality, right? The test of normality. As this sample is more than 50, we have to look at this Kolmogorov-Smirnov test. So the Kolmogorov-Smirnov test, this is the p value. The p value is less than. For example, the p is less than 0. This values, right? This values is 0. Must be p must be greater than equal 0.05. If it is there, we can conclude that data is normally distributed. Then data is normally distributed. So this is what the finding. So this is what as undergraduate students usually for our first level of graduates, undergraduates usually focus on this statistical analysis must cover. For example, what descriptive analysis, categorical data analysis, and other one is correlation and the regressions. And next one also the independent sample test, one-way ANOVA test, and like that we have to do. For example, a one-way ANOVA, independent sample t-test means the two. For example, we have to look at the comparisons on this populations mean. Populations mean among these two groups. For example, male and the female. Sometimes the faculty, accounting faculty, business faculty, we have to compare the marks between the two faculty marks. One is business faculty students and statistical exam that are simultaneously conducted, for example, for accounting students and the management students. In such a case, we have to compare whether this populations mean or differ between accounting students and business management students. So in such situations, we have to look at this independent sample t-test. And also, if there is a more than two variable, let's say, for example, you are going to measure the salary categories, right? First category is you have to compare the salaries of the all employees. First category is 22 to 20,000 to 40,000, one category. Second, 40,000 to 50,000, second category. 50 to 60 is the third category. and 60 to 80 is the fourth category. 80 to 100 is the fifth category, and then thousands above, 100,000 above is the sixth category. Let's say, for example, you have a sixth category of salary scale, right? You have to compare these, compare the populations mean among these different category of salary group. So that situations we have to look at the one-way ANOVA test and all, right? And how these different salary groups are going to be like, different or not, no difference among this group. Is there any difference or no? So that's what we can look at. In addition to that, in advanced version, for example, we have got this correlation and the regression. So based on that, based on this value, right? Correlation and the regression. And in addition, in this data screening and all, we have to test the reliability and the validity test. Reliability and the validity test. For example, all the students must test the reliability. Okay, I will explain this reliability, how this can be tested, right? Okay, so I'm going to remove this all the drawing, and I'm going to share this data. Okay, the data is visible right now, and we have to have a move. For example, STR. What is the reliability of this STR? Okay, click the analysis and look at here a scale. We have to click the scale and reliability analysis, right? Okay, so if we click this reliability, I'm going to test the STR only. For example, STR, I have take a move to this STR, and okay, I'm just move not all this 4, right? For example, right. For STR, I'm going to have a move STR 1, 2, 3, 4. What is the reliability of this STR? Right. Okay. Click on this one and look at here. This STR reliability of Cronbench alpha. Cronbench alpha source here 0.525. 0.525. According to the rule of thumbs, rules, right? If these the Cronbench alpha is greater than 0.7, it is very good, excellent, right? So some cases, if it is a Cronbench alpha is less than 0.05, so it's mean the reliability among these four item, it mean the question 1, question 2, question 3 is mean the item or indicators we see. So among these, the consistency among these 4 items is less reliable. So anyhow, if it is a 0.525, acceptable, right? But it is a preferred. It is preferred if it is 0.7, greater than 0.07, it is very good. It may be go 8, 9, and all. So that means the excellent. See, among these four measures or 4 question, it's a reliable. We say we are going to conclude it's a reliable. So the next level, the factor analysis. The next one is the factor analysis. Before that, we have to test the validity also, right? I'll show this validity, how we can set it. And for example, we have to go to analysis, dimension reduction, and click this factor. Okay, I'm going to reset this one. And we have to have a move first STR1 to STR4, right? We have to take a move to this variable area, right? So STR1, STR2, STR3, STR4, right? So this is the advanced exploratory factor analysis. I'm going to have a move with this exploratory factor analysis, because exploratory factor analysis explain what? If there is a less research conducted, it is the new research that you are going to explore to the world. So where the exploratory factor analysis is important, right? So that is what, for example, if you have done some in-depth analysis, in-depth research, firstly that you are going to you developed this variable, sub-variable and or sub-variable item indicator, and based on that develop the questionnaire and all. Now you are going to test into this field, right? So that is what the EFA, exploratory factor analysis, can be used. So that we have to click here descriptive. Descriptive, we have to click this univariate descriptive, and second one coefficient, and third one the KMO, right? KMO stands the Bartlett's test of sophisticity, and click continue. And extraction. Extractions, there are a lot of methods are available under the factor analysis. First one is, for example, the principal component, maximum likelihood. These are the two mainly used by the researchers, but the principal component analysis are mainly, most of the researchers are using this principal component analysis, right? After that, no need to put anything, and click OK. And the rotation, how these values are going to be rotated among these item. So that the mostly there are two options are available, Varimax and the Promax. Varimax and the Promax are used. Mostly, most of the researchers use the Varimax or Promax. So click on the Promax, no issue at all. And the scoring, so no need to save as a variable. After that, as we have already calculated the average value, this factor loading, this is the factor analysis, will give us one value. That means it will load all the factors and bring one variable, right? As we did for average value and all, define the one variables like that. So this is the different way that it is a loading, right? Theoretically, you go and search something, so factor loading and all. Right, click on, right? No need on save as a variable, right? Click on continue, click OK. So once you put here, this will explain to you the descriptive statistics. What is the mean value of the STR1, STR2, STR3, STR4? This is the standard deviation. So all these value for STR1, STR2, STR3, the mean value is above 4, right? Not less than the 4, right? Okay, good. And when you compare this correlations matrix, STR1, STR2, STR3, STR4. So this is the column wise and this vertical and the horizontal side. You look at here, the values for STR value, there is a rule of thumb is available. This is what we are going to compare here. Inter-item correlations. So we have to define that as the term inter-item correlation. One is because inter-item mean we are going to compare the STR1 and STR2 here, STR1 and STR3, STR1 and STR4. Like that, we are going to compare among these all items. So that is what we look at here, the diagonal value. For example, STR1 and STR1 always 1. There's no more changes. STR2 and STR2 is 1. STR3, that's 1. So that is mean the relationship within for a one variable. But we have to compare the relationship STR1 and STR2. So rule of thumb says that if the value is less than, for example, less than 0.3 and less than 0.385, so the value must fall between 0.3 and 85, 0.85 and 0.3. Within this value only, the value must be placed here. Unless, for example, if the value is less than 0.3, we have to remove. If the value is 0.85, greater than 85, that also must be removed. Right? These two variables, two items are not suitable for this study. Statistically, it says that. Right. For example, here we look at here STR1. These values are all three values compared to STR1 to STR3, STR2, STR1 to STR3, STR1 to STR4. All values are less than 0.03. So because of that, we have to make sure is the value is between this area. So what we have to do it, we have to remove that item and do this next analysis, right? Okay, I'm going to remove these, right? str1, click OK. All right, okay, now look at here. Now look at here. So according to this correlations matrix, all the values are fallen between 0.3 to 0.85. 0.3 to 0.85. So these results are accepted, right? And also we have to find the value of the KMO, right? So this is what it is called. This is what is called, for example, convergent validity. You can have take a note on see that there are different type of validities are there: phase validity, content validity, and discriminant validity, right? There are a lot of convergent validities. A lot of things are there. So just find the notes and read it right carefully. Okay, so look at here. All values are here between this range. So this is accepted. These three item only accepted. Like that, we have to compare these values. That is what calls the KMO values, Bartlett's test. The Bartlett's test is a significant. This is the significant. This values is a greater than 0.5. This is greater than 5. So according to the criteria, this validity, the overall validity of the STR is stronger. All right. And we have to compare another item, another table. Right. Okay. And we have to look at here the total variance explained. The total variance explained means there are three items are there. If the total variance is more than that means the cumulative values greater than 50%. 50%, it is accepted. It is accepted. If it is greater than 50%, so this STR is a one variable is accepted. All right, we can do the further analysis based on this result. And furthermore, we have to compare this component matrix. For example, this is the additional values. If the values is greater than 0.5, it is acceptable. But as it's all these values are 7, more than 7, excellent. This is the excellence value. So this is what I wanted to give you additionally. This is not yet finished this factor loading. I just explained for only one variable, but we have to load all the 4 variables. For example, all 4 variables value together, right? So we have to run like this and value together. We have to form the different 4 variables, right? So that is what is called factor loading. It will be covered under the EFA, exploratory factor analysis. So I just finished only the one part of this EFA, not completed, right? Because today's sessions only covered for this descriptive correlation and regressions at a basic level. In advanced level, we can have a move to the exploratory factor analysis, confirmatory factor analysis, and the mediating analysis and moderating analysis and all through the SPSS also. So there are other softwares also it's available, other statistical tools also available, structural equations modeling also, that is there are different tools are available from this SPSS IBM software. So AMS also used, it is a powerful tools for structural equations modeling. So as the time is given by the coordinator, by Dr. Riyadh, is just for the maximum time is 2 hours, right? So I'm just in line with my time. It's started by 6:30. Now it's 6:30, 8:32. Am I right, Dr. Riyadh?
Yes, sir.
Dr. Riyadh?
Yes, sir. Yeah.
Right. Yeah. Is that all right? Is enough, or may I extend the session?
So we have enjoyed a wonderful session. So now, Selvi sir, so if you don't mind, shall we open for Q&A, question and answer from the
Yeah,
audience?
right. Okay, of course, definitely, right, definitely. So,
Any students? If you have any questions, we can ask. Any questions? Okay.
some students ask the physical class and all, right? If it is the possible, or the physical class also possible, right? No problem at all to me to the at the university level, at a faculty or the university level, uh, right? And is there any question? So you may raise question right now, okay? And in future, if you have any problem, right, in technically, if there's any issues in the analysis part, no problem to contact me, right? My numbers and email is available with the coordinator. You can have a contact with him, and I will be able to give you so full support in any time.
Thank you very much, Professor Dr. Halim. So we have enjoyed a wonderful session. So today's session is more than enough to complete the undergraduate research, even in master research. So you have shared your wonderful knowledge. So as we know, so you are the most busiest person in our faculty. So you have allocated your valuable time for the betterment of our student and the faculty. So we are working for the common goal that we have to enhance the research culture of our university. So for that, we are working for that. So I hope all the students will get benefit out of this session. So thank you very much again for our resource person, Professor Dr. Halim. And also I express my sincere thanks to our audience, our students, and other staffs and other external members. So thank again, and thank you very much. And also, so again, I extend my sincere thanks to our faculty members and the Dean of our faculty, Dr. Safina Hassan. So she has given an approval to conduct this session continuously. So now it's the time to wind up the session. Thank you, Professor. Shall we, sir? Thank you, sir.